interior angles converse theorem. And in order to prove this, we need this postulate over here that I wrote, which is the corresponding angles converse postulate, which basically says that if corresponding angles are congruent, then the lines are parallel. So for example, if I find out that 6 is congruent to 2, then I know L is parallel to M immediately based upon this postulate. I use this in conjunction with the vertical angles theorem to show that if I have, like I do, I'm given that 3 is congruent to 6, which, 3 is congruent to 6 is a pair of alternate interior angles. I'm given that they are congruent, and the way that this is going to go is I'm going to say 3 is congruent to 6 because that's given. Then I could say 6 is congruent to 7 because they're vertical. And then I know since 3 is congruent, 3 is the same as 6, 6 is the same as 7, that must mean that 3 is the same as 7. And if you look at the relationship between 3 and 7, they're corresponding. And I use the postulate to finish this off because now I say 3 and 7 are corresponding and they're congruent, therefore L is parallel to M. So let's write this out. So I have that's given, then I'm going to say 6 is congruent to 7 because of vertical angles theorem. And now I have that since 3 is the same as 6, 6 is the same as 7, it implies that 3 is congruent to 7. This is transitivity. And then I finish off with saying that, well, 3 is congruent to 7, 3 is corresponding with 7. And I use this postulate here to say that then the lines must be parallel. L is parallel to M because a pair of corresponding angles are congruent. If a pair of corresponding angles are congruent, then the lines are parallel. Corresponding angles converse postulate, and you're done.